Hello and welcome to a video explaining about section 903 of the textbook, the shape of a distribution. So looking at shape and what does shape mean and what does distribution mean. These are equally important for the work for this week, but also because this will be in the test on the 29th. So shape, dealing with probably like the trend in the data that you see. Usually they use things like this as a bit of a curve to outline the trend. So if we did a line graph as well, you can see that's basically the shape, and the distribution is how the data is spread from the lowest to the highest, from the bottom range to the top range. So with this shape idea, we've got the first word is symmetrical. Now, symmetrical meaning the thing like this distribution, this shape and this shape are both symmetrical, where the high point is right in the middle. The mode, or the most number of scores, is right in the middle, and you get an even spread to the left and pretty much the same on the right hand side of it. So that if you did a line down the middle and folded it just like in symmetry, that curved line will be symmetrical about that line there. Symmetrical. Same with this one. We've got a low point, the curve gradually reaches up to the high point right in the middle and then fades away towards the top. So there's our symmetrical. What's to say? The data is evenly spread or balanced about the centre. Evenly spread is the key. Evenly spread about the centre. Okay. Now you can see obviously these two are not symmetrical because you've got, there's the centre, and it's definitely not evenly spread about the centre here or here. There's our centre. We've got a bit of a massing of data. This one is to the left of centre. And when that happens, it's called positively skewed. Skew meaning it's like off centre. The data is bunched or clustered at one end. So when it's clustered on the left-hand end or the lower end, it's positive skew. When it's clustered on the right-hand side, on the higher end, it's a negative skew. So there's skew. I think of skew as the opposite of common sense, because if it was, I would think, if data was clustered down the lower end, it's a negative skew. But no, they call it positively skewed when its lower end is bunched up, and negative when it's higher end. So there's two words. We've got symmetrical and skewed. Positive, negative. So I suppose there's three terms. The fourth one is bimodal. Now the mode is an indication of the score with the highest frequency. And bimodal means there's two peaks in the data, just like this. We've got our actual mode, which is 6. But we've also got a very clear high point at 2. So when you high point and another high point, when there's two of them, that's bimodal. And some examples here, we've got a question, describe the shape. So we're going to use those symmetrical, skewed or bimodal words. And then we'll have a look at these ones here. So shape. Now symmetrical, obviously not. There's the centre. And all the data is skewed to the right-hand end, which makes that a negative skew. So the shape of this one is a negative skew. There's no multiple high points, so definitely negative skew. This one, the mid point is about here, and the data is bunched on the lower end, so that's a positive skew. The idea of outliers is a score that's obviously way below or way above the bulk of the other scores. If you look here, see obviously 10 is a lot lower than the next highest scores. So we've got an outlier at 10 here. And not quite so obvious because the dot plots show it well, but here we've got 84 followed by 98. So that's a gap of 14 marks. And then another gap of 13 between 84 and 71. So we've got a couple of outliers there. Mark, that's obviously higher than the rest. And just to show you in another context is the marks we got for the last term's test. This is the distribution of the scores. We have an outlier down here. We have, well, there's the centre there. So most of the data is skewed to the right, and we've even got bimodal, 2 high points, one at 33 and another one at 38. So you could say this is a couple of things. It could be called it bimodal, but you'd also call it negative skew because most of the data is on the higher end. Let's go back. Okay, let's go back to here. So a couple of questions you've got to do, looking at, I'll just pick a couple of these. Obviously here, bimodal. Here is bimodal, but also it's the inverse of a symmetrical as well. Outlier, because it's a long way higher than the rest. This one here, the centre's there, so the data is skewed to the left, which makes it a positive skew. This one here is a negative skew. We don't have too many outliers in here. There's an outlier with that one, and then the rest of it is skewed to the right, which makes it a negative skew. We have a bit of a bimodal thing happening with this one. A positive skew here because the data is bunched towards the lower end. We have a lower end bunch here, so that's a positive skew, and an outlier at 92. Okay. And so the rest of the question is based on knowing about the symmetrical, the skew, the bimodal, and then outliers. And then the other one term we haven't covered is clustered. So we've got here, in this one, question 5, 26 is the lowest score, and the next lowest score is 53. So an outlier is certainly there, a lot lower than the rest. And so I'm just trying to see if I can find an example of clustered data. And the best way to see it is in a stem and leaf. Let's have a look here. This may be a good example of clustered. We've got 32, 34, 36, 37, 38, 38, 39. Well, 6, 7, 8, 9 and 9, there's a number of scores that are close together. 36, 37, 38, 39, 8, 39. There's an example of a cluster, clustering from 36 to 39. So there's your cluster. I think that will cover us all. Thank you very much, everyone.